Stay classy, Golden Eagles. So this is going to be the follow-up to the first of the quadrilateral lessons. Remember, quadrilateral is a four-sided figure. It's a four-sided shape that has four angles, okay? So that was the first lesson. Now this one is where we're going to get a little bit more in-depth and a little bit more challenging, okay? So this may end up being 1 or 2 videos. We'll just see how long this one takes. I usually like to keep them around 5 to 6 minutes. So our learning goal is today is that we're going to be able to classify, okay? Classifying or name triangles based on their sides and whether things are parallel. So before we get into the difference between a square, a parallelogram, a rhombus, and a trapezoid, we need to identify some key terminology that we're going to be using for the rest of this week. The first one is one you guys should all be familiar with. One of the key terms that you should all be familiar with is the word parallel. Parallel means that two lines that if continued on to infinity, they will never cross. So if I had two perfectly straight lines and if they continued upwards or downwards, and they would never cross, therefore they're parallel. These are not parallel lines. They will continue and hit. These would be parallel lines. They'll continue on as long as they were perfectly straight and they will never cross, okay? The other thing that I want to review is something from last week. Maybe actually it might be 2 weeks ago, but that is acute, obtuse, and right angles. So we are going to be talking a little bit about angles in terms of our quadrilaterals, our four-sided shapes. So acute is a very small angle. They are small and cute. A right angle is where two straight lines meet up perfectly and make a 90-degree angle. And an obtuse angle is where it's bigger than 90 degrees. So if this is 90 degrees, obtuse would be anything past that. Anything from there to about there. And acute is anything less than 90 degrees, okay? The other key thing that I want you guys to know about before we get started on classifying quadrilaterals into 5 different types of quadrilaterals is that if you measured in a four-sided figure, a quadrilateral, if you measured the angles with a protractor, and we'll work on this here coming up here pretty soon with a digital protractor, every four-sided figure that is contained, that is closed, that doesn't have an opening, okay, is going to equal to 360 degrees. Now, for a triangle, that was always going to be 180. For any four-sided figure, it's always going to be 360 degrees, all right? So the first one that I want to take a look at today is this figure. And this is the first of 5 figures that we'll look at. And this one is a trapezoid, okay? Trapezoid. All right, a trapezoid can be classified as a trapezoid, or you'll know if it's a trapezoid if it only has one pair of parallel lines. Now let's look at the lines. We have this line and its partner across it. Usually, we'll talk a lot about lines and we'll always go the one across it, not the one that it connects with, but the one that is across from it. So if we look at this line and we looked at this line and we continued these lines on perfectly straight with our ruler, and continue them on, they would cross. Therefore, they are not parallel. Now let's look at the other set of lines. We have this top line and this bottom line. If we continued them on left or right and continued them on way off into the page, they would never cross. They are parallel. So right there, we know that this is a trapezoid because this line and this line are parallel and these two lines are not, okay? So that is a good indication of a trapezoid. Trapezoids have acute angles, they can have obtuse angles, and they can have right angles. Now, all of these guys are going to be, these two angles at the bottom here are acute angles because a straight line would be perfectly up here and it's slightly turned in. If we turned this upside down to get a better look at the top two angles, you'd notice a perfectly straight line would go up right about this. So these top two are obtuse. So this particular trapezoid has 2 obtuse angles and 2 acute angles, and all total, they'll equal 360 degrees. So a quick reminder, a trapezoid has only one pair of parallel lines. This line, if you continued it on up, would meet up at some point up top here. It would meet up and they would cross, so therefore they're not parallel. But these two lines, if you continue them either direction, would not cross. Therefore, they are parallel. So a trapezoid only has one pair of parallel lines. The next one that I want to look at is called a parallelogram. Okay, and there's some keys in there. There's a key term in that word, and that's parallel. So this is an example of a parallelogram. And a parallelogram has opposite sides are parallel, and they are of equal length. Okay, so let's think about it really quickly in terms of the top and the bottom lines. Okay, these two lines, if they continued on left or right, if they continued on, they would never cross. Same thing with these two lines. If they continued on vertically or down, they would never cross. Okay, so therefore these two are parallel and these two are parallel. Now what makes this even more unique and special is that the opposite sides are the same exact length. Okay, and I know that because I measured them correctly. So if I remember correctly, I measured this as 5 inches, these two lines as 5 inches, and these two as 4 inches, okay? And that's a distinction between a parallelogram and a square. It's not that all 4 sides are the same length, it's that the opposite sides are parallel and the same length. Okay, that's going to be the end of the first video. I'm kind of maxing out on time, so there will be a second video where we'll go over the final 3 shapes that I want to teach you. As always, stay classy, Golden Eagles.